Assalamualaikum warahmatullahi wabarakatuh. Kita mulakan SPS 4120 by Fizik 2 untuk week 1, lecture 1, lecture number 1. Okay, so we want to see the structure of biomolecule. So for that we need to do some revision of organic chemistry. So I hope you learn the organic chemistry in your CFS or in your form 5. Okay, so here these are our cell. Okay, so each part in the cell consists of biomolecule. So let's say that like a membrane, cytoplasm, DNA, nucleus. Okay, so all composed of the biomolecule. Okay, so biomolecule is the elementary building block for our cell. So what are the elementary building block? Okay, so every living thing. Okay, so in this diagram or in this protein, okay, so consists of hydrogen H 60.5%, oxygen 25.7%, carbon 10.7%, nitrogen 2.4%, phosphorus 0.17%, and sulfur 0.13%. Okay, so that is a combination of things in or matter in our protein. Okay, so we also consist of this element playing the role of electrolyte. Okay, so electrolyte meaning that it conduct electricity. Okay, so when it become an ion, so it can conduct the electricity, whether it's a strong electrolyte or a weak electrolyte. Okay, so we have calcium 0.23%, sodium 0.07%, potassium 0.04%, magnesium 0.01%, and chloride 0.03%. And also we have two transition metal ion. Okay, so these are carry an electron by combining with this, let's say, iron and copper. So when electron combine with this iron and copper, so if it release from, let's say, ferrum 3 plus becoming ferrum 2 plus, so we are going to have one, ferrum 2 plus becoming ferrum 3 plus, so we are going to get one free electron. Okay, so it can carry the electron anywhere in our body. Okay, so these are the standard building block of the biomolecule. Okay, so we can see here, let's say this block, red, yellow, green. Okay, so consists of carbolic acid. Okay, so this is from our organic chemistry. So with a general formula RCOOH. So when we put in neutral water, so it is associated to an ion RCOO minus. So then we have alcohol with the general formula ROH, and then we have monosaccharide or the carbohydrate. So we have a general formula CH2O and N, meaning it repeat it again and again and again. So but it generally with N equal to 5 pentose and N equal to 6 hexose. Okay, C only the length, the chain length only N5 or N6. So it can be N100, N1, N200, and any number, but usually it's only N5 and N6. Next is we have the amine with a general formula NH2R. Okay, so N is the nitrogen, so which in neutral water environment, protonate and become cation. So you can see that NH3 plus 3 plus R. Okay, so can be N cation. And next is we have that nitrogenous heterocycle. So here we change one carbon in our benzene to nitrogen, so it become the nitrogen can move around in that benzene ring, for example. Okay, so next is we have the phosphate. So we have general formula RPO32 minus. So dissociate into the water environment, okay, and making the phosphate bond. Okay, and next is the last one, hydrosulfide with general formula RSH. So this one is in our amino acid, some of the amino acid. Okay, so it can make the sulfide bond. Okay, when combine making the protein folding. Okay, so we have this. So R denote the additional chemical entities. Okay, so we have this whatever C. Okay, so these are the functional group for some of the biomolecule. So for carbohydrate, so we have aldehyde, CH, okay, CHO, ketone, C double bond O, and ROH alcohol. Okay, next we have the fatty acid, C double bond O plus OH. Okay, so we have this carbolic acid. Next is we have the protein. Okay, again the carbolic acid and also the amine NH2. Next we have nucleic acid. Okay, DNA. So we have the alcohol ROH and the phosphoric acid. Okay, so these are our DNA. So first we see the carbolic acid. Okay, so the carbolic acid, the functional group of the carbolic acid is called a carboxyl group. Okay, so this is just a repetition of our chemistry class. Okay, C double O and OH, or COOH or CO2H. Okay, so we can write. So it much is better to write in this form when we show the structure. Okay, and these are for writing. Okay, so we have can be either aliphatic or aromatic. So here we can see that if aliphatic, there is no benzene ring, and is aromatic, so we have this one, the benzene ring. Okay, so we have these are the benzene. So these are just, for example, this one CH3. Okay, so how can we classify the carbolic acid? So we have first saturated carbolic acid. So here we can see that C and this C. Okay, so we have the single bond. So this also we have a single bond. Unsaturated carbolic acid. Okay, so we have some of the C. We have a double bond between the C and C. Okay, on this one C and C, and this one C and C, a double bond. So next is the aromatic carbolic acid, the benzene ring. So we can see that here we have the acid. This also carbolic acid, and this one also we have the aromatic carbolic acid. Okay, so toleric acid, toleric acid. So the last one is the dicarbolic acid. So we can see here CC. These are carbolic acid, and this one is also the carbolic acid. Okay, so we combine two, making this double or dicarbolic acid. Next is the hydroxy acid. Okay, so here we have carbolic acid plus the OH. Okay, OH, 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 and OH. Okay, so we have this hydroxy oxygen. Okay, so this one. And the last one is the amino acid. Okay, so the amino acid. So we can see that we have the nitrogen here. Okay, and we have this COOH. Okay, so these are one functional group, and this also one functional group. Okay, so these are the amino acid, one of the amino acid. So next we go to the carbolic, the alcohol. Okay, so alcohol. So an alcohol is an organic compound with in which an OH group is bonded to a separate carbon atom. Okay, CH3OH, CH3CH2OH. Okay, you can see that these are single bond, single bond. Okay, so next is the how we classify the alcohol. So we have this primary alcohol, secondary alcohol, and tertiary alcohol. Okay, so here you can see that it only one extension R, and this one double R, and here we have all other places are populated with R. Okay, R, chemical entities. Okay, so we have this tertiary alcohol. Okay, so we can see this. So these are some of the name of the formula and the type, the name of alcohol. Okay, so we can see that one carbon atom CH3OH, methanol, uh, two carbon atom ethanol, three carbon atom, one propanol, two propanol, and four carbon atoms. So we have four isomer, one butanol, two methyl, one propanol, two butanol, two methyl, two propanol. Okay, so we can see this is what we are trying to say in biophysics uh, 3. Okay, so it can be in this configuration, this configuration, this configuration, and this configuration. So how many in this configuration? Let's say 100 uh, CH4H9OH. So how many in this configuration? This one, how many in this configuration, and how many in this configuration? So here we can see that for C5, so we can see that we have 8 config or 8 isomer for this alcohol. Okay, so at certain temperature, which one is the most probable uh, isomer for this alcohol, or for this chain C, whatever these are, C5. So next we have this monosaccharide, the carbohydrate. Okay, so here carbohydrate are used by essentially by all cell as an energy source. Okay, so these are we store kalau dalam kereta minyak in our body, these are carbohydrate as our energy source. And monosaccharide is a carbohydrate that cannot be hydrolyzed to simpler carbohydrate unit. So macam atom jugalah, kan? So, atom adalah yang paling kecil yang kata-kata. Okay, or now is pion, clone. Okay, so and then monosaccharide is the basic carbohydrate unit of cellular metabolism. Okay, so this one. Okay, so how we can classify the monosaccharides? As we say that it uh, we can have n chain, the chain up to 100, 200, 300, 400, but the most common one is the triose, tetrose, pentose, hexose, and heptose. Okay, so these are C3, C4, C5, C6, C7. Okay, so here like I said, the monosaccharide can have any number of carbon greater than 3, but only monosaccharide of 3 to 7 carbon are coming found in in our world. Okay, so these are okay. So this one as triose. So we have the second one is as aldose or ketose. Okay, so what are aldose and ketose? So we can see from our chemistry textbook. Okay, so an aldose is a monosaccharide that contains an aldehyde functional group. Okay, so we have this OH. Okay, this one CCC is a OH next to the alcohol. Okay, COH. And the ketose is a monosaccharide that contains a ketone functional group. Here we see that here C double bond. Okay, C double bond. Here C double bond with oxygen. So these are the ketose. And next is the again for the configuration and isomer. Okay, as a D dextrorotatory or L levorotatory isomer, depending on the special orientation of the H and OH group attached to the carbon atom adjacent to the terminal primary alcohol group. Okay, so here you can see that if this one D HCOH, so these are the configuration if H is in our left and if H is on our left right, so L configuration. Okay, so these are the terminal out of ROH. Okay, and this one L glucose and D glucose, D fructose, this one. Okay, so L glucose, so you can see that here H is at the right side, OH at the left side. Okay, and again here D glucose, OH is at the right side and H in the left side. Okay, so we have this for the monosaccharide. Okay, so these are the our monosaccharide. So next is the amine. Okay, so amine is an organic derivative of ammonia. So we have NH3. Okay, in which one of or more alkyl, for example the methane, this alkyl is methane. For cycloalkyl is the ethyl benzene, and aryl is the CH3. Okay, so we have this aryl group replaced by ammonia hydrogen atom. Okay, so we have this or R3N, so you replaced by replace NH. For example, we have NH3. We replace one of H with the COOH, for example. Okay, so become an amine. Okay, so here we can have the classified as this amine classified as primary, secondary, or tertiary on the basis of how many hydrocarbon group have replaced ammonia hydrogen atom. Okay, so here these are ammonia NH3. So we can see this NH3. So primary amine, so one hydrogen is replaced by this R. Secondary amine, so here you can see that this H is replaced by R prime, and tertiary amine, so all H has been replaced by the other molecule. Okay, so this one R double prime. Okay, so CH3 and CH3, CH3. Okay, so we can get this as primary, secondary, or tertiary amine. Okay, but we can see that all are contain the nitrogen N. So next is, like I said, the nitrogenous heterocycle. Okay, so we have the benzene ring. So but here we modify this aromatic hydrocarbon, which a few hydrogenated carbon CH are replaced by the nitrogen. Okay, so here For example, this one is supposed to be C, 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 but we replace it with N, so it becomes pyridine. Here again, we replace with N, and we have a double bond here, so meaning that it can move around, so the N can move around, so we get, okay, so here I go again, we replace 2C with N and N, and here we replace 1C with N. This one also we replace 1C with N. This one we replace 2C with 2N, and this one we replace 1C with N, and here we replace 4C with N. Okay, so this one meaning that this N can move around. Okay, so these are the nitrogenous heterocycle. Okay, so it can move around this ring. This one cannot move, but here the rest the N can move. So the next one is the phosphorus. Or phosphate. Phosphorus is most commonly encountered in biological molecule in organophosphate compound that contain a phosphorus atom bonded to 4 oxygen, with one of the oxygen also bonded to the carbon. Okay, so we have P, O minus, O. Okay, so these are double bond. So these are O negative, these are O, CH3. Okay, so usually we can find it in our adenosine triphosphate and adenosine diphosphate, ATP and ADP. Okay, so here we have the ATP, we change it into ADP, so we are going to get some energy. Okay, so we can get the energy. So here we can see that the phosphate 1, 2, 3. So this one only 1 and 2. Okay, so these are the one of the way we can get the energy, a quick energy. Okay, a quick energy. So the last one is the hydrosulfide. Okay, so it contains a sulfur S. Okay, so these are two of the amino acid that has sulfate. Okay, so the first one is cytine, SH. Okay, and this one methionine, methionine. Okay, so we have also this S. Okay, so by connecting or making a long chain with this 7 biomolecule, so we can get in this one, for example, the protein. Okay, so here you can see there we have the H, the sulfur, so the sulfur can make a bond, sulfide bond, so it can strengthen the our protein. Okay, or making the protein to full to whatever condition that it interact. Okay, so that is the, so here again we see that hydrogen bond electrostatic interaction, so we are going to see in the biophysics 3. Okay, so I think we can, that is all for this lecture number 1. So thank you.